Hi everyone, and welcome to the Allplane Podcast about the innovators and entrepreneurs that are transforming the aviation industry. First of all, my usual reminder that you can find all previous episodes of this podcast, as well as many other aviation stories, on our website, Allplane.tv. That's ALLPLANE.tv. Check it out. We have often talked about electric aircraft on this podcast, but we have said very little about a very essential piece of the electric flight story, the batteries. Richard Wang is the founder and CEO of Cuberg, a startup based in California that is currently working on some of the most advanced lithium-metal battery technologies, to the point that earlier this year, Cuberg was acquired by one of the major players in the battery industry, Northvolt of Sweden. Northvolt, that has already signed multi-billion-dollar deals to supply batteries to some of Europe's largest car manufacturers, is also looking to supply the emerging electric aviation industry. And by acquiring Cuberg, it got hold of a technology that seems to hold the key to that emerging sector. Cuberg claims that its technology can deliver a 70% performance improvement over the current generation of lithium-ion batteries, which makes its technology an object of attention for the emerging eVTOL urban air mobility industry, and could also potentially power regional all-electric aircraft in the near future. But I think it's best if we hear about all of this directly from Richard. Let me welcome him to the podcast. Hi, Richard. How are you?
Good. Happy to be here, Miguel.
Thank you very much for accepting to be here in the podcast. You are working on a technology that is so essential for an emerging segment of the aviation industry, and that's electric batteries. You're the founder and the CEO of Cuberg, a US-based company that was recently acquired by Northvolt, which is one of the main players in new generation battery technology. I think it's very interesting to have you here to learn more about this fascinating area of scientific research that is going to soon have lots of applications in mobility, including air mobility. Can you tell us a little bit about yourself and about Cuberg, how you started this company, and what's your background?
Sure. So my background is as a scientist and engineer. I went to undergrad at Caltech in mechanical engineering, and then went to pursue my PhD at Stanford in materials science, studying battery materials. And I really got interested in battery technology because I saw it as one of the key bottlenecks for the transition to electrification and a renewable energy economy. So I studied battery materials throughout my PhD there. And then near the end of it, I came up with, was really thinking about how to make an impact on the world. What I had seen at the time was that a lot of innovations that were happening in academia were not successfully making it out into industry and really having a clear impact and value on the world. And even the ones that had been launched into startups that had attracted a lot of funding and interest, many of them have struggled or have gone bankrupt because it's incredibly hard actually to commercialize a new battery technology. And the realization that led to the founding of Cuberg really was that the key challenge in battery technology is not just about materials, but really at the end of the day about cost-effective manufacturing and scalability. If you cannot scale it up and be compatible with the existing manufacturing ecosystem, then you cannot compete with lithium-ion batteries. So when I founded Cuberg, I really wanted to create a battery startup that was really operated in a very, very different way, focused much more practically and pragmatically on how to do innovation in a realistic way and ensuring that everything that we do is fully compatible with the lithium-ion manufacturing process. And so that's what we've done over the past 5 years, and we've been very happy with how things have progressed so far. At the core of what we do is a new battery chemistry, a lithium metal chemistry that delivers up to 70% more energy per weight compared to the existing lithium ion batteries and can be fully manufactured with existing processes. And so this has really attracted a lot of interest in the electric aviation community, particularly where weight is so critical for the success of these vehicles. So we've been very happy to pursue this industry. And now that we are now part of Northvolt, we're also looking at the longer term picture for further scaling this up for mass market automotive applications as well.
Yeah, I think we are getting a bit ahead of ourselves, because I wanted to ask you about the link with Northvolt. So you're a very young company, startup, and then you got acquired by Northvolt, which is a Swedish battery company that has been all over the place recently, because they are building this huge factory in the north of Sweden. They have signed super huge contracts with some of the automakers in Europe and in other places. And then they basically acquire you because of the technology you were developing, right?
Mm-hmm. Yes, exactly. So the vision of the acquisition with Northvolt has really been that Northvolt it has tremendous capability for manufacturing at very large scale, and this is reflected in their investments coming into the company and in their significant orders from big automakers. But they're looking for what's coming after existing lithium-ion technology, what's coming next. And when I met Peter Carlson, the CEO there, a couple years ago, I think we immediately saw sort of a natural fit between the two companies. And it really was because of this vision of manufacturing scalability. At the end of the day, this is critical not only for efficiently commercializing, but also for making sure we can get a technology out into the marketplace as quickly as possible and with as much scale as possible. Mm-hmm. And so the ultimate vision for Cuberg's technology is, as it becomes fully matured, it can really drop into Northvolt's existing production lines and convert all that capacity that they've already built out and reuse that and allow it to jump to the next generation of performance and technology.
So for the time being, you remain as a separate unit. You continue to operate autonomously with your team in the US. I don't know if it's accurate to say that, but basically the part of the Northvolt group that is more focused on aviation technologies or in technologies that have promising application for the aviation industry.
Correct. So Cuberg is now functioning as a semi-independent entity within Northvolt. We align at a high level on strategic direction and vision, but then most of the day-to-day operational decisions are still made internally as they were before, and we continue to operate as a startup in California. Our two main responsibilities are to serve as the Advanced Technology Center of Northvolt, to conduct advanced research both on lithium metal and broadly for batteries as a whole. And our second responsibility is to serve as Northvolt's aviation business unit. And so because we've already built all these great relationships with the aviation community, we're well positioned, especially with our new technology coming into the marketplace, to really build up this new business for Northvolt in electric aviation.
How many people you have there in the US, in the Cuberg team?
We have now close to 40 people, and we're quickly growing. So Northvolt is investing quite a few resources, both in our R&D capabilities as well as in manufacturing and process scale-up. So we're hiring very rapidly, but yes, currently about 40 people and running a whole lot of projects all at once. It's a very, very exciting time.
Yeah, I had a look at your website and I see you have a very prominent job listings there. So I just invite everyone that has an interest in this field and is in engineering to go and check it out. It looks very interesting. You mentioned lithium-ion technology, which is the current, let's say, mainstream technology in batteries, but you are working on something a bit different, which is a lithium-metal technology. Mm-hmm. Can you guide us through what are the differences and why this lithium-metal technology is more promising than the current generation of batteries?
Sure. So in a lithium-ion battery, you have a cathode and an anode. These are the materials that actually store the energy, that store your lithium ions. And then you have an electrolyte. It's a liquid that contains the lithium ions that shuttle it back and forth as you charge and discharge your battery. And so those are the three sort of major components of a typical lithium ion battery. Most of the weight of the battery is typically coming from the cathode and the anode materials that store the energy. And so what we've done is replace the traditional anode, which is a carbon-based graphite material, with a pure lithium metal anode. So rather than having this host structure of carbon, we don't have any kind of host or containing material. It's just pure lithium that actually is just electrode deposited and becomes a metal. It's just a pure lithium metal. So this is actually the lightest possible anode material in the periodic table for any battery. So it's the holy grail of anode materials. And that's how we're able to get such significant weight savings in our technology. The lithium metal is intrinsically paired with the electrolyte design though, because lithium metal by itself, because it's so energy dense, is very unstable and reactive typically, and it will decompose a lot of the standard electrolytes that you use. And so our core innovation really is designing this lithium metal cell and inventing a new electrolyte that helps to stabilize the lithium metal surface, and that is also a non-flammable electrolyte that helps with promoting improved safety compared to existing solutions.
One of the big issues with batteries is that there were some concerns about some batteries just burning for some reason, creating a safety, a hazard, particularly in planes. That's a big safety concern. With your technology, that would be less of a problem, from what I understand.
Yes, and so we have a significant focus on cell safety. And so safety, in our view, goes really across the spectrum. It starts at your materials design level, it goes to your cell design, where we're innovating on cell safety, and it also goes to the systems level. How do you engineer a module and a system that goes into your plane that is fault tolerant and resistant to propagation of cells catching on fire? So we're developing technologies across the spectrum to ensure that when this does go into a plane, it has the maximum reliability and safety needed.
And when it comes to aviation, where are we now in terms of using this technology at, let's say, at an industrial scale? And what would be the most immediate applications? I mean, we are seeing lots of activity in things like the eVTOLs, then also some regional aircraft, normally in the smaller categories of aircraft, also for some regional flights. Even some concepts, some startups are aiming for larger aircraft. In your opinion, what would be the path for this technology, and what's the time frame you envisage for this?
So I think this is partially a certification question as well, in terms of which vehicles will have a faster pathway to certification. So I think right now the lowest risk vehicles tend to be retrofitted fixed wing eVTOL vehicles that, rather than using fossil fuel, uses a battery and propellers. So whether it's fully electric or hybrid electric, we see that as being very close to initial commercialization.
One thing, just when you say eVTOL, it's conventional takeoff and landing, right?
Exactly.
As opposed to vertical takeoff and landing, the eVTOL. I'm just making the note here because I'm not sure everyone in the audience might be familiar with this term. So the certification, how hard is it to certify a battery like this? I mean, you would need to go to the FAA. What's the time frame for that?
Right. So the certification process, we haven't started it yet because that requires first working with a customer closely to design your module for their performance requirements. And then after that, then you can take it through certification. So we anticipate starting that process at the end of 2022. And then after that, taking another probably 1 to 2 years, depending on FAA or EASA bandwidth. And I think the process for that, high level, is essentially, it's something called DO311A is one of the critical FAA standards, and there's a similar one in Europe. And essentially, it talks all about the safety and reliability of the battery. And the test you have to pass is you have to artificially simulate one cell catching on fire somehow, whether you're burning it or you're putting a nail through it or something else, and then making sure that as that cell burns out, your system can still operate, your vehicle can still stay in the air, and the fire doesn't spread to any of your other cells in your system. And so that's, at the end of the day, the critical test to pass while still being very lightweight and efficient in your system design.
And what's the performance improvement compared to the current generation? Because at the moment, there are some serious limitations, and that's why we are seeing most of the aircraft we are seeing powered by batteries are pretty small. Well, there are some concepts that are a bit larger, but mostly they are in these 2 to 19 passengers. What is the performance improvement that you expect to bring about with the lithium metal technology that you're developing?
So our technology delivers up to about 70% more energy per weight compared to existing batteries. And so simply put, if you take an existing plane and put our batteries in it for the same weight, you can have a payload or a flying range that's about 70% longer. So it's a very significant increase in flight range. We see this as having a significant impact for the eVTOL, the fixed wing aircraft, but I think an even bigger impact for eVTOL, vertical takeoff. And the reason is that these vertical takeoff aircraft tend to be less energy efficient and are much more demanding on their batteries. And so most of the eVTOL designs typically tend to have shorter flight ranges compared to eVTOL. And so in eVTOL, that industry is more challenging from a regulatory and certification perspective, but ultimately we believe it'll become a much bigger market and also become a much stronger adopter of advanced batteries because of how sensitive they are to battery performance.
Is the vertical takeoff and landing more demanding on batteries?
Yes, it is substantially more demanding, especially on the takeoff and the landing phases. Mm-hmm. It's probably on the order of maybe 3 times more power out of the battery. So it's a significant drain.
Is there going to be industrial capacity to serve this industry? I mean, we are seeing now many orders for hundreds of these eVTOL aircraft. Where are we on the industrial side of things? I mean, assuming that the technology is certified, the batteries are certified and green lighted by the FAA, EASA, etc. Are you going to be part of Northvolt industrial infrastructure? Are you planning to build a new plant?
Yes, so I think if you look at the commercial adoption timeline, near term, most aviation customers are using existing off-the-shelf lithium-ion batteries for their first generation of aircraft, just because that's already existing and they can go to certification with that. So that supply is available and they can run demonstration flights and early commercial flights. But the challenge is those batteries are so heavy that they cannot realize the full potential of their vehicles or their business models. So it'll only be useful for sort of these niche early applications. As you want to really push this into the mainstream and cover a much larger portion of your operating model, then you need to jump to something like a Cuberg technology. And so we are in preparation to really serve all that demand coming down the pipeline. We anticipate commercial use of the Cuberg's advanced battery technology for actual commercial aviation applications somewhere in 25 to 26, which lines up with a certification pathway and entry into service for some of these key customers we're working with. And so we are in the planning stages of building up more and more production capacity, and we'll certainly have abundant capacity by the time these vehicles are ramping up operations. If you look at Northvolt, they have, for automotive, it's a whole different order of magnitude of volumes that they're dealing with. And so aviation, even as we're talking about hundreds or thousands of aircraft, is still a very small volume in terms of the battery landscape. So certainly we'll be able to support that with a high quality certified aerospace production line.
Building it in America?
We're likely looking at building it in the US. Final decision and site selection hasn't been made, but a lot of our early customers are in the US, and this is also where Cuberg is based, so it seems sensible for at least for the first production step. And then, of course, we will also look at expansions into Europe as depending on our customer profile.
And I guess other industries as well, not just aviation, but you are also looking at possibly at other applications in mobility?
So right now we're primarily looking at aviation because that is the major early market that really benefits from the lightweight batteries. There are some other ones near term. For example, electric trucking is one that we see as pretty promising. Even though you think of a truck as this bulky, massive vehicle, it actually, from a battery perspective, has a lot of similarities to aviation because they're also very, very weight sensitive. If we want to carry a lot of payload, you just can't have many tons of batteries in your truck. And so electric trucking is one area that is closer to Northvolt's core expertise, but where we think we can add a lot of value. And then longer term, more 2027 and beyond, that's where we see then maybe larger automotive applications coming into play.
And what about the life cycle of the batteries? How long is the life of those batteries? How many cycles are they expected to sustain?
Yeah, so cycle life typically for a lithium-ion cell will be roughly 1,000 cycles when you use it. And these are full cycles from top to bottom of charge when you're using it in some of these demanding aviation applications. For Cuberg, top to bottom of charge right now, we are getting close to 500 cycles. So we've made pretty substantial improvements over the past few years, but we still have a little ways to go to get to that 1,000. And that's what we'll be developing in the next 2 years is improvements in our technology and chemistry to get to that 1,000 cycles.
And when it comes to the charging itself, are there any differences? It's just like charging an electric car?
Exactly. From a charging and systems perspective, it really is very, very similar to existing batteries for electric aviation. And, it'll be higher power than an electric car just because these tend to be much larger systems, at least several times, maybe up to 10 times bigger in battery size compared to an EV. So you'll need maybe more specialized charging infrastructure at an airport. to power them. But otherwise, essentially the same concept.
How long can it take to charge a battery powering an eVTOL, for example?
So I think, most companies are looking, if you look, for example, at the eVTOL space, most companies are looking at partial use of their battery each flight to extend the lifetime of their battery, and also to have some reserve in case of emergencies or anything else. So when you're looking at those partial charges, people are looking at something like a 15-minute charge time, and so that's roughly appropriate amount of time also for passengers to get off, to load luggage and so forth, and then you can be charging at the same time. So it fits well with their high utilization business model. So about 15 minutes for like a partial charge that might be maybe 40% of your total battery capacity.
Okay. And when it comes to the business model and how it fits into this whole ecosystem that is emerging in electric flight, electric aviation, and urban air mobility, where do you fit? I mean, do you have alliances or partnerships with some of those manufacturers, or it's going to be a ready off-the-shelf technology that basically anyone could potentially acquire? Is there going to be, I don't know, like even a secondary market for batteries, for replacements? How do you envisage this market being structured when it becomes a mainstream thing?
Yeah. So right now we're working with a few of our most promising customers as launch customers, essentially, for our battery technology. And there we're taking a pretty custom approach where we're designing the first generation of our cell and our module specifically for their vehicle design.
Sorry, the customers would be the companies that are developing the eVTOL.
Correct. These would be the vehicle companies that we're directly working with. And so we're custom designing these first generation specifically for that aircraft. And then beyond that, the longer term vision is that development turns into really a reference design that any vehicle manufacturer can use. And they can either take that reference design and directly integrate it into their vehicle, or if they need a different shape, then it's not difficult to then further change the shape to integrate into their vehicle. So then this smooths out the ability for customers to adopt it. I think on the other side, when you're looking at end of life, this is something where Northvolt also has done a lot of work on battery recycling. And so I think either looking at second use of batteries, these aviation batteries at end of life will still have a lot of life in them, just maybe for less demanding applications compared to aviation. So you could use them for some maybe grid applications and so forth. And then ultimately, they have to go into recycling to make sure the whole process is ultimately sustainable. And so that's where we will be relying on Northvolt's expertise on cell recycling to ensure that we're able to offer customers this full end-to-end solution for batteries.
Looking even farther into the future, how do you see this market evolving? Where do you see electric flight and batteries going from here? I mean, not the next decade, but let's say 20, 30 years into the future. Do you see pure electric flight becoming a thing as batteries get better, or is going to remain a sort of a segment focused on the shorter haul and the urban air mobility? You're on top of the technologies that are only now starting to be researched. What can we expect?
So the reality with battery technologies is there are some intrinsic limits in terms of how much energy can be stored based on known or even imagined technologies out there. And right now we're offering a 70% improvement compared to existing batteries. If you look at all of the sort of speculative ideas out there, you might get another, let's say, doubling in energy density, but you're not going to get a 10 times increase in energy density even over the next several decades. And so this is just the reality of sort of some of the electrochemical limitations of batteries. And so what this means for the electric aviation sector is really battery powered aviation will be more limited to eVTOL as well as short, maybe medium haul flights. I think especially when you're looking at hybrid electric, you can get to significant kind of medium haul distances, 1,000 kilometers, maybe 2,000 kilometers with a good hybrid electric plane that has maybe 50 or 100 passengers. But when you're talking about really kind of the transcontinental type flight, batteries just don't have the sufficient energy density. They're too heavy still. And when you're talking about really long range flights, long haul, that's really where alternative solutions, either hydrogen fuel cells or synthetic fuels that are basically pulling CO2 from the atmosphere to create jet fuels will probably ultimately still be the preferred solution for long haul.
Definitely some other interesting technologies we've covered here in the podcast as well. In any case, it looks like the eVTOL scene is going to be pretty busy in the few coming years. For people that want to learn more about Cuberg and about your technology, where should they go?
Our website, Cuberg.net, would be a great place for people to find more information. And then if they're interested in further inquiries, we have a press link as well, press@Cuberg.net.
Okay, great. So I think that's been a great introduction to the technology of batteries. That is such an essential part of the eVTOL revolution that we are witnessing now. And I would just invite everyone to go check your website, check Northvolt website as well, because they are also doing pretty interesting stuff, especially this huge factory they are building in northern Sweden. It's going to supply other industries like car manufacturing, etc., which are also part of the electric revolution. So thank you very much for coming today here on the podcast.
Thank you, Miguel. We have a lot of exciting things coming up in the next year, and hopefully can look forward to some more exciting announcements from Cuberg and Northvolt.
Thank you very much, Richard. Take care.
Thank you. It was my pleasure to be on your podcast.
Before you go, and if you like this podcast, a quick reminder that it would be absolutely great if you could please give it a rating on Apple, Spotify, or whichever platform you're using, or recommend it to a friend or whomever might be interested. Thank you very much, and see you soon.